Hello and welcome to helpyourmath.com. In this video, we are going to go over some important information and definitions of the graphs of transformed sine and cosine functions. Let's start with two definitions. The amplitude of a graph y equals a times sine of x or y equals a times cosine of x represents the height from the midline of the graph to the highest point on the graph. Or it is half the height from the lowest point to the highest point, or we can say that it's the height from the midline to the lowest point on the graph. So three different ways we can interpret amplitude. We can determine the amplitude of the equation of a sine or cosine graph by taking the absolute value of a. So the amplitude, it's a distance, so it's non-negative. It's the absolute value of a. So on a sine graph, if the sine graph has a positive a coefficient, it would look like this. And what the amplitude is, if this is the midline, is it's the distance from this midline to the top of the graph. This is a distance of a, or from the midline to the bottom, that would be to the lowest point, that would be a distance of a. And same would be true for a cosine graph. So cosine looks like this. The midline would be halfway there. So from the top to the middle, this would be the amplitude a, or from the middle to the bottom, that's an amplitude of a. The period of y equals sine of bx or y equals cosine of bx represents the length of one complete cycle. And this is where sine and cosine functions are a little bit different than the functions that we've seen before. Previously, with all other functions, I don't think I ever once had a coefficient of x, ever. So this is something new, and it's very common with our sine and cosine functions. We want to get used to x having a coefficient for sine and cosine. Okay, but to determine one complete cycle or one complete period, so that period that's from the start of one to the end, so that's one complete cycle or one complete period, it hits every single point that it's ever going to hit, every, up to the max, down to the bottom, back to the beginning. And for the cosine, it starts at the top or the bottom, and it goes back to the top or the bottom. That's called a period, and that length is 2 pi divided by b. So to determine the period, from start to finish of one cycle, that's 2 pi divided by b. Okay, let's put these definitions to good use. Let's determine the amplitude and the period for the graph of each of these two equations. First, we have y equals 2 times sine of 4x. A from the equation is 2, and b is equal to 4. To determine the amplitude is the absolute value of a. That would be the absolute value of 2, and the absolute value of 2 is 2. So the amplitude is 2. And remember, what does that amplitude tell us? That tells us that from the middle of the graph, the midline to the top, that's a distance of 2. Or from the midline to the bottom. To determine the period, we take 2 pi and we divide it by b. So we don't just say that the period is 4. Nope. We plug it into a little equation or a little expression. We get 2 pi over 4. We can simplify this because both the numerator and denominator have a factor of 2, and we end up with pi over 2. So this sine graph, one period, one cycle, would go up first since it's positive, down, and since it's sine, it starts at the midline. It's saying that from here to here, this is a distance of 2, and it's saying that from the start to the finish, this is a distance of pi over 2. So they're both referring to different to distances. One is the vertical distance and one is the horizontal distance. How about this cosine function? How about this cosine function? In this case, a is equal to -3 and b is equal to +5. The amplitude would be the absolute value of a, and that's going to be the absolute value of -3, which is 3. The period, remember we set up the little expression, 2 pi over b would be 2 pi over 5. What this tells us about this cosine graph is that because a is negative, right, it's -3, we start at the minimum instead of the maximum. So we go from the minimum through the midline up to the maximum, back down to the minimum. So the midline's right in the middle, and that means that from that minimum point to the midline, this is a distance of 3. And from that minimum to the next time we see a minimum of the graph, that's a distance of 2 pi over 5. That's amplitude and period. But there's so much more about our sine and cosine graphs. We're going to focus for a minute on sine functions. What is sine of 0? Right, so if we think of the unit circle, or if you just happen to know it off the top of your head, sine of 0 is 0. Great. What that means, and we saw this with the parent function, is that the sine parent function started at 0, 0, right? That parent function started at 0, 0. But like we've seen with other functions, sine graphs can also have transformations. So where we would normally have a starting point, a quote-unquote starting point, right? Because actually it extends to negative infinity, but we have to start somewhere. So where we would normally have a point of 0, 0, where would this point be if we have the equation g of x equals a times sine of bx minus c plus d? And let's go through a few more definitions to be able to answer this question. First, a sine graph or a cosine graph, and we're going to focus on sine. So we have this whole mess here of a transformed function. We'll have something called a phase shift. That is the horizontal movement in the graph. In the past, we've seen that horizontal movement because it was just the value of c, right? It moved left or right depending on the value of c. But there's a little bit more going on here because of that coefficient of xb. To determine the phase shift, to determine how much it moves left or right, we do c over b. And you might be saying, wait a minute, why is that? Well, because remember what the goal here is. We're trying to figure out what happened to this 0. How did it move based on what we're given? And so what we want to say is we want to say, okay, well, this should have been 0, right? This was originally 0 in our parent function. Now we have bx minus c. So how does that affect the graph? Well, we set it equal to 0. We get bx is equal to c. We divide both sides by b, and there's that c over b. So what happens is if we plug in c over b for x, we would end up getting 0 there, right? Because we'd have b times c over b minus c. The b's cancel, we get c minus c. So there's that 0. Then we have sine of 0 is 0. 0 times a is 0. 0 plus d would give us d. So that's why we have this phase shift. That's why it's no longer just c, it's c over b. So that's the movement left or right. The vertical shift is determined by the value of d. In fact, every sine curve has a midline. That's a horizontal line that every other point that we draw lies on. So when we sketch sine functions, we focus on 3 key points. We focus on the maxima, the minima, and the midlines, the points that lie on the midline. And we draw the curve to represent all the points in between those. But we really just focus on those 3 key points, and every other point when we're graphing and we focus on those 3 points, we'll hit the midline. So the midline is really important because that's every other point when we graph, and that's determined by y equals d. So we have this midline, we have the shift in the graph. What is this new point now? So what would have been 0, 0 is now going to be, well, the horizontal movement was c over b. And then when we plug in c over b, remember what happened? This whole thing turned to 0, leaving us with just that vertical movement of d. So the sine functions will have a starting point now of c over b, comma, d. This is a lot to go over. Let's make it practical and look at it by breaking down an equation. So our first equation, let's label a, b, c, and d. A is equal to 2, b is equal to 1/2, c is equal to 0, right? Because this is, there's nothing being added or subtracted within the sine function. If we wanted 3 to be included in there, then it would have to be inside a set of parentheses. It's not, so that indicates to us that d is equal to 3. Okay, the amplitude, remember how we find that? That's the absolute value of a. That's going to be 2. The period, we have 2 pi over b, so we're going to substitute in 1/2 for b. This is 2 pi over 1/2. Be really careful when you're plugging in a fraction into a fraction because you don't want to lose the original fraction. How do we simplify this? Because this is now a complex fraction. Well, this is 2 pi divided by 1/2. Remember, we can rewrite division as multiplying by the reciprocal. So this becomes 2 pi times 2 over 1, which is 2 pi over 2. And, oh, the fraction's gone. We have a period of 4 pi. I know that was a little bit of trickery, so review those complex fractions again if you need to. But the answer is 4 pi, not pi. Pi is wrong. That's not it. It's 4 pi. What's the equation of the midline? Well, the equation of the midline, this is y equals d. So the midline would be y equals 3, substituting in 3 for d. And 1 point, so instead of 0, 0, what point would be on this graph? Well, 1 point is going to be found by doing c over b, comma, d. C is 0, so it's going to be 0, comma, 3. So whereas the parent function starts at 0, 0, or we start it at 0, 0, this one, we would start our graph or our one period of the graph at 0, 3. Okay, let's look at our second example for sine. So we have A here is 2/3, B is 2, C is pi over 7, and D is -1. The amplitude is the absolute value of 2/3, which is 2/3. The period is going to be 2 pi over B, which would be 2 pi over 2. There's that pi, so the period is pi. From start to finish of one cycle, it will be pi units. Notice here, we do get pi because we divided by 2, different than what we did in that first example. The equation of the midline is going to be y equals d, so this will be y equals -1. And how about this single point? So this point, we're going to do c over b, that phase shift, comma, the value of d. So c over b will be pi over 7 divided by 2, another complex fraction, so we have pi over 7 divided by 2 over 1. We can multiply by the reciprocal. We get pi over 7 times 1/2, and we end up with pi over 14. So this is going to shift pi over 14 units to the right and down 1 unit. Instead of starting at 0, 0, or where we're going to start a period, we're going to start this period at pi over 14, comma, -1. That was sine. Now we're going to talk about cosine. What is cosine of 0? Well, cosine of 0, think back to our unit circle, is 1, right? Because 0 is at the point 1, comma, 0, and cosine is the x value. So cosine of 0 is 1. A normal cosine graph, and by normal I just mean the parent function. The parent function of a cosine graph has the point 0, 1. That's where we start one period of the cosine graph. However, just like we saw with the sine functions, cosine also can have transformations in the coordinate plane. So whereas a cosine graph would normally start at 0, 1, what about when we have a transformed cosine graph? Let's review these definitions again. So the cosine graph will have a phase shift, that's that horizontal movement, and the phase shift is going to be the same for cosine as it was for sine, c over b. There will also be a vertical shift determined by the value of d. Every cosine curve has a midline. That's a horizontal line given by y equals d. But here's where cosine can get a little bit more difficult than sine, because when we're trying to determine the new point, the new 0, 1, we don't just get to plug in c over b and d the way we did with sine. What changes is that y coordinate, that starting y coordinate. So what we have to do, what I like to do with cosine, is start with that midline. The midline is the center of our universe. We're going to start with the midline, and then we're going to use this value of a to help us decide where that starting point is. So if a is positive, then the starting point will be a units above d. So this is going to be a plus d. If a is negative, actually, sorry, I'm going to change that to d plus a. If a is negative, then it will start below d, because we would do d plus a, but a is negative, so it's going to dip below d. Therefore, on a transformed cosine curve, 0, 1 is now located at our horizontal shift stays the same, but our vertical shift is going to be d plus a, where you keep the sign of a. So notice we're using lowercase a. This is not the amplitude. Lowercase a is going to help us determine that starting y coordinate. Okay, so let's look at 2 examples. We want to determine the amplitude, period, midline, and 1 point on each graph. First, I'm going to determine A, B, C, and D. So we get A here is 1/3, B is 4 over 5, C is 0, and D is 3. Amplitude, remember how we find that? This is the absolute value of A. The absolute value of 1/3 is 1/3. The period, remember this is 2 pi over B. Let's try that again. 2 pi over b. This would be 2 pi over 4 over 5. Whoops, complex fraction alert. This is going to be 2 pi, I'm going to put it over 1, divided by 4 over 5. We can rewrite by multiplying by the reciprocal. That's 5 over 4. I'm going to just simplify this. Okay, so we end up with 5 pi over 2. Yikes. Okay, so the period this time is 5 pi over 2. So that's from the beginning to the end of one cycle is 5 pi over 2 units. The equation of the midline, so remember the midline, this is y equals d, and this will be y equals 3. And last but not least, 1 point. So instead of 0, 1, what is going to be 1 point? And remember how we determined that? It's c over b, comma d plus a. So c over b, since c is 0, the x-coordinate will still be 0. The y-coordinate, d, 3 plus 1/3 is 3 and 1/3. So this graph will start at 3 and 1/3, then it will go down to 3, then it will go down to 2 and 2/3, back up to 3 and 1/3. And we're going to do more examples of that. So I know that was a lot to absorb right there. I just want to focus on these 4 things. So hopefully you're still with me on these 4 things. Okay, last example for this particular presentation. We have a is equal to, this would be -1, b is equal to 3, c is equal to pi over 5, and d is equal to -6. All right, the amplitude, this is the absolute value of a. The amplitude is +1. The period is 2 pi over b. So in this case, b is 3, so the period is going to be 2 pi over 3. The equation of the midline, that's y equals d, so it's going to be y equals -6. And 1 point, so the point is c over b, comma d plus a. c over b, this is going to be pi over 5 over 3. That's pi over 5 divided by 3, which I'll put 3 over 1. That's the same as pi over 5 times 1/3. Woo! And the starting x-coordinate for this period will be pi over 15. So we have pi over 15 is x. And what about our y-coordinate? That's going to be -6 plus -1. We're going to start down at -7. These have been the definitions and examples of finding the amplitude, period, midline, and 1 point on a cosine function and a sine function. Thank you for stopping.